Students, in the last class we discussed about the general properties of group 16 elements. So this group 16 elements commonly called as chalcogen. Why? Because they form easily ores, okay na? In the form of ore, that is oxide or sulfide, we are going to get, okay na? Then generally we call this, since oxygen is the first atom, we call this as oxygen family also. So here we have oxygen, sulfur, selenium, tellurium and polonium are the elements. So we learnt about the atomic properties. So in that we learnt metallic character, right? So since oxygen is a highly electronegative comparatively, means completely group 16 ಅಲ್ಲಿ ನಮಗೆ ಕಂಪೇರ್ ಮಾಡಿದಾಗ oxygen is highly electronegative element. Actually here the metallic character increases down the group, okay na? So ಇದೊಂದು ಮಿಸ್ಟೇಕ್ ಆಗಿತ್ತು, change it. So metallic character increases down the group. Why? Because see here oxygen and sulfur are non-metals, whereas selenium and tellurium metalloid and polonium is a typical metal present in group 16, okay na? So here the metallic nature increases down the group, while coming down the group the metallic nature increases, okay na? So next we have oxidation state, reactivity towards hydrogen, oxygen and all, okay na? So next we are going to read about the chemical properties. So under chemical properties, coming to first one, that is oxidation state, okay na? So here particularly oxygen is the highly electronegative and its oxidation state in most of the compound is -2, okay na? So oxygen anta consider madidre it is highly electronegative and it is having oxidation state -2, okay na? That is common oxidation state. Then even it shows -1 oxidation state in peroxide form, okay na? Peroxides and superoxides ಅಂತ ಬಂದಾಗ ನಮಗೇನಾಗಿರುತ್ತೆ -1 ಇರುತ್ತೆ. ಸೂಪರ್ ಅಂತ ಬಂದರೆ -1/2 ಇರುತ್ತೆ ಸೂಪರ್ then +1 in OF2, O2F2 and +2 in OF2, okay na? So oxygen particularly it exhibits general oxidation state -2, but in case of peroxides -1, superoxides -1/2, O2F2 +1, OF2 +2, okay na? So actually the stability of -2 oxidation state decreases down the group due to decrease in the electronegativity. So ಇಲ್ಲಿ particularly ನಮಗೆ ಈ ಗ್ರೂಪಲ್ಲಿ oxygen is most electronegative. So since the electronegativity decreases down the group, -2 stability of -2 oxidation state decreases, okay na? So -2 oxidation state ಏನಿದೆ ಅದರದ್ದು stability decreases while coming down the group. That is due to decrease in the electronegativity. Due to decrease in electronegativity. Then other elements shows, usually remaining element shows +2, +4, +6 oxidation state, okay na? +2, +4 and +6. Here +2 and +4 is common oxidation state, okay na? So +4 and +6 is common oxidation state. So particularly this group 16 elements show +4 oxidation state, +4 oxidation state when it is combined with oxygen. Oxygen ಜೊತೆ combine ಆದಾಗ it shows +4 oxidation state, whereas it shows +6 oxidation state when it combines with fluorine, okay na? Generally this group 16 element shows +4 oxidation state when combined to oxygen and +6 oxidation state when combined to fluorine, clearly. So stability of +6 oxidation state decreases down the group, okay na? So +6 oxidation state, the stability again it decreases. Why it decreases? Due to inert pair effect. As you already know inert pair effect, so due to this decrease in inert pair effect, the stability of +6 oxidation also decreases. Next coming to reactivity towards hydrogen. So how this group 16 elements reacts towards hydrogen? So generally it will react with hydrogen to form respective hydrides. So it is having general formula H2E, that is where E represents group 16 elements, okay na? So for example H2O, H2TE, then H2S, like that it goes on. Okay na, group 16 elements form reacts with hydrogen to form respective hydrides in the form of H2E, where E refers to group 16 elements. Next, what are these properties of hydrides? ಹಾಗಿದ್ರೆ ಹೈಡ್ರೈಡ್ಸ್ ಪ್ರಾಪರ್ಟೀಸ್ ಏನು ಅಂತ ಹೇಳಿ. ಸೊ ಯೂಶಲಿ ದ ಥರ್ಮಲ್ ಸ್ಟೆಬಿಲಿಟಿ ಡಿಕ್ರೀಸಸ್ ಡೌನ್ ದ ಗ್ರೂಪ್. ಓಕೆನಾ, ಸೊ thermal stability of these hydrides decreases down the group. That is due to decrease in the bond dissociation energy. Okay na, that is due to decrease in the bond dissociation energy of EH bond in hydrides. Okay na, so EH bond dissociation energy ನಮಗೆ ಡಿಕ್ರೀಸ್ ಆಗ್ತಿರೋದ್ರಿಂದ even the thermal stability also decreases. Okay na, so basically these hydrides of group 16 are weak acids. Okay na, basically these are weak acids. The acidic strength increases down the group. Okay na, acidic strength increases down the group. So it is having the order that is H2E less than H2S less than H2SC less than H2TE. Okay na, so from H2O to H2TE it increases down the group. Clear? So ಹಾಗಾಗಿ the acidic strength ಏನಾಗುತ್ತೆ, that is having the order like this. Next, these metal hydrides provide hydrogen for reduction process. So reduction process ಗೆ ನಮಗೆ ಏನಾಗುತ್ತೆ, addition of hydrogen takes place, right? So for that this metal hydrides gives or provide hydrogen, hence they act as good reducing agents. Okay na, these hydrides acts as a good reducing agent. So particularly the order of reducing strength increases down the group. So it increases down the group, that is in the order that is from H2S to H2TE. Okay na, ಅದಕ್ಕೆ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ಯಾಕೆ ವೈ H2O ಮೀನ್ಸ್ ಅಂತಂದರೆ H2O it is not a reducing agent. Okay na, H2O does not act as a reducing agent. So the reducing, it acts as, particularly these group 16 hydrides acts as a good reducing agents. So that increases down the group, that is from H2S to H2TE. Okay na, then particularly H2O is a liquid. As you already know, H2O is a liquid where H2S is a gas. Okay na, H2O is a liquid where H2S is a gas. This is because of the greater electronegativity of oxygen than sulfur. Okay na, comparatively ನಮಗೆ oxygen and sulfur, oxygen is more electronegative, right? So that's the reason ಏನಾಗುತ್ತೆ ನಮಗೆ H2O is a liquid, H2S is a gas. And one more thing, H2O here there is a presence of intermolecular hydrogen bonding. Okay na, so what do you mean by hydrogen bonding? Means an electronegative element combined with your hydrogen, we call it as hydrogen bonding, right? So there is a presence of hydrogen bonding between hydrogen and oxygen, whereas hydrogen and sulfur anta bandaga there is no hydrogen bonding. Okay na, so hence H2O is a liquid whereas H2S is a gas. Clear? So particularly in this H2S gas it is having a weak van der Waals force, hence it exists as a gas. Clear? So while reasoning they will ask this question, H2O is a liquid where H2S is a gas. Why? One thing, here oxygen is more electronegative than sulfur, and one more thing, there is a presence of intermolecular hydrogen bonding in water, that is between hydrogen and oxygen, whereas there is no intermolecular hydrogen bonding in hydrogen and sulfur. Instead there is a presence of van der Waals force in H2S, hence it acts as a gas. Clear? So this is about the properties of hydrides. Coming to next chemical property, that is reactivity towards oxygen. So how this group 16 elements reacts with oxygen? So particularly this group elements reacts with oxygen to form two types of oxides. So oxygen ಜೊತೆ react ಆಗಿ it will form two types of oxide, that is EO2 and EO3. Okay na, EO2 and EO3. So particularly here E refers to group 16 element except oxygen. Okay na, clear? So it will form oxides respectively, that is EO2 and EO3 form. Okay na, both these oxides are acidic in nature. Actually both form is acidic in nature. Okay na, particularly except we have except POO2 is amphoteric. What do you mean by amphoteric? Acidic, amphoteric. So actually adu nimage next concept ide, types of oxides. So in that I will explain you detail. Okay na, so very simple. Acidic means it acts as a acid. Okay na, acidic nature irutte. Amphoteric, it acts as both acid as well as base. Okay na, next and here one more thing, that is SO2 is a gas where others are solids. Okay na, others are solids. Then this reducing property, based on this reducing property, actually particularly SO2 is a good reducing agent, whereas tellurium oxide is a oxidizing agent. Okay na, SO2 is a good reducing agent, whereas tellurium oxide is a good oxidizing agent. That is because of particularly in the sulfur. So sulfur we have +6 oxidation state is more stable than +4 oxidation in case of sulfur. Okay na, in case of sulfur +6 is more stable than +4 oxidation state, hence it acts as a reducing agent. Okay na, whereas in tellurium oxide +4 is more stable than, in tellurium particularly +4 is more stable than +6. Okay na, that is due to inert pair effect, hence here tellurium oxide acts as a good oxidizing agent. So next coming to fourth one, that is reactivity towards halogens. We have general representation, that is X2, right? Halogens, that is fluorine, chlorine, bromine, iodine. Okay na, so here particularly these elements, I mean group 16 elements reacts with halogen to form respective halides in the form of EX2, EX4 and EX6. Okay na, EX2, EX4, EX6. So here only fluorine forms hexafluorides. Okay na, only fluoride with fluorides it form hexafluorides. Okay na, means in the form of EX6 ಅಲ್ಲಿ ನಮಗೆ ಸಿಗುತ್ತೆ. Usually this stability decreases down the group due to decrease in the electronegativity. Okay na, while coming down the group the electronegativity decreases. For this reason stability decreases down the group. Stability decreases down the group. Okay na, then among this EX6 particularly EF6 is more stable. Okay na, clear? So particularly here E undergoes sp3d2 hybridization. So and they have octahedral structure. So particularly with respect to EX6 type of halides, EF6 is more stable. Here E, I mean that particular element, whether it may be oxygen, sulfur, tellurium, selenium, polonium, okay na, group 16 elements that undergo sp3d2 hybridization and exhibit octahedral structure. Okay na, so and one more thing, SF6 is most stable hexahalide. Okay na, so it is the most stable hexahalide among EF6, means ella elements compare madidre SF6 is most stable halide. So here 6 fluorine atom protect the sulfur atom from the attack of reagent. So any other attack means ಬೇರೆ ಯಾವುದಾದ್ರೂ ಸಲ್ಫರ್ ಜೊತೆ ನಮಗೆ ಅದು ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ, ಐ ಮೀನ್ ಬೇರೆ ರಿಯೇಜೆಂಟ್ಸ್ ರಿಯಾಕ್ಟ್ ಆಗೋದನ್ನು ಅದು ಏನು ಮಾಡುತ್ತೆ, ಇಟ್ ಪ್ರೊಟೆಕ್ಟ್. ಓಕೆನಾ, ಸ್ಟಾಪ್ ಮಾಡುತ್ತೆ. ಹೆನ್ಸ್ SF6 ಈಸ್ ಮೋಸ್ಟ್ ಸ್ಟೇಬಲ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಅಮಾಂಗ್ EX4 ಸಾಲ್ಟ್ಸ್, ಓಕೆನಾ, ಐ ಮೀನ್ EX4 ಹ್ಯಾಲೈಟ್ಸ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ SF4 ಈಸ್ ಮೋಸ್ಟ್ ಸ್ಟೇಬಲ್. ಸೊ ಹಿಯರ್ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ undergoing, ಓಕೆನಾ, ಸೊ ದಟ್ ಈಸ್ sp3d hybridization and having bipyramidal structure, ಓಕೆನಾ, bipyramidal structure. ಸೊ ಇಟ್ ಎಕ್ಸಿಬಿಟ್ಸ್ ಸೀಸಾ ಜಾಮಿಟ್ರಿ. ಸೊ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ ಈಕ್ವಟೋರಿಯಲ್ ಪೊಸಿಷನಲ್ಲಿ ನಮಗೆ ಲೋನ್ ಪೇರ್ಸ್ ಇರುತ್ತೆ, ಐ ಮೀನ್ ದಟ್ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ದು ಲೋನ್ ಪೇರ್ಸ್ ಇರುತ್ತೆ. ಸೊ ದೇರ್ ವಿಲ್ ಬಿ ಎ ಡಿಸ್ಟಾರ್ಷನ್ ಇನ್ ದ ಜಾಮಿಟ್ರಿ. ಡಿಸ್ಟಾರ್ಷನ್ ಅಂತಂದರೆ ಸ್ವಲ್ಪ ಡಿವಿಯೇಷನ್, ಓಕೆನಾ. ಹೆನ್ಸ್ ದ ಬಾಂಡ್ ಆ್ಯಂಗಲ್ ಡಿಕ್ರೀಸಸ್ ಫ್ರಮ್ 180 ಡಿಗ್ರಿ ಟು 173 ಡಿಗ್ರಿ, ಓಕೆನಾ. ಯೂಶ್ವಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ ನಮಗೆ ಬಾಂಡ್ ಆ್ಯಂಗಲ್ ಡಿಕ್ರೀಸಸ್ ಫ್ರಮ್ 180 ಟು 173. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯು ಹ್ಯಾವ್ ಅಮೋನಿಯಾ, ಆಯಿತಾ, ಅದರಲ್ಲೂ ಅಷ್ಟೇ ನಿಮಗೆ ಕ್ಲಿಯರಾಗಿ ಗೊತ್ತಾಗುತ್ತೆ ಬಾಂಡ್ ಆ್ಯಂಗಲ್ ಹೇಗೆ ಡಿಸ್ಟಾರ್ಷನ್ ಆಗುತ್ತೆ ಅಂತ ಅಂದ್ಬಿಟ್ಟು. ಸೊ ಹಾಗಾಗಿ 180ಇಂದ 173ಗೆ ಅದು ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಹೆನ್ಸ್ ಇಟ್ ಎಕ್ಸಿಬಿಟ್ ಸೀಸಾ ಜಾಮಿಟ್ರಿ, ಓಕೆನಾ. ನೆಕ್ಸ್ಟ್ ಕಮಿಂಗ್ ಟು EX2 ಟೈಪ್ ಆಫ್ ಹ್ಯಾಲೈಟ್ಸ್ ಅಂತ ಬಂದಾಗ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ undergoing sp3 hybridization, and here there is a presence of 2 lone pair electrons. Here it is having a bent structure like water, it's having a bent structure, ಓಕೆನಾ. ಸೊ EX6 ಅಂತ ಬಂದಾಗ here E undergoes sp3d2 and octahedral geometry, whereas EX4 ಅಂತ ಬಂದಾಗ that is E undergoes sp3d and bipyramidal structure, whereas EX2 ಅಂತ ಬಂದಾಗ E undergoes sp3 hybridization and having a bent structure like water, ಓಕೆನಾ. ಸೊ this is about the reactivity towards halogen. So coming to next one, anomalous behavior of oxygen, ಓಕೆನಾ. ಸೊ ಹಿಯರ್ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ದ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಆಕ್ಸಿಜನ್ ಬಿಹೇವ್ಸ್ ಇಟ್ಸ್ unique features. So why it behaves or the reason behind this anomalous behavior, that is due to small size, high electronegativity and non-availability of d orbitals. So students, so here oxygen exhibits anomalous property because of its small size, high electronegativity and non-availability of d orbitals, okay na. So next coming to the what are the anomalous property, means simple ಆಗಿ ಹೇಳೋದಾದರೆ what is the difference between oxygen and other elements, okay na. So here particularly oxygen exhibit diatomic in nature, I mean O2 ಅಂತ ನಾವು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ, ರೈಟ್. ಸೊ O2 ಅಂತ ಹೇಳಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಡೈಅಟಾಮಿಕ್, ವೆರಾಸ್ ಅದರ್ ಎಲಿಮೆಂಟ್ಸ್ ಎಕ್ಸಿಬಿಟ್ಸ್ ಆಕ್ಟಾ ಅಟಾಮಿಕ್, ಓಕೆನಾ. ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ S8 TE8 ಲೈಕ್ ದಟ್, ಓಕೆನಾ, ಇಟ್ ಗೋಸ್ ಆನ್. ಸೊ ಏನಾಗುತ್ತೆ, ಅದರ್ ಎಲಿಮೆಂಟ್ಸ್ ಎಕ್ಸಿಬಿಟ್ಸ್ ಆಕ್ಟಾ ಅಟಾಮಿಕ್ ಇನ್ ನೇಚರ್. ನೆಕ್ಸ್ಟ್ ಇನ್ ಆಕ್ಸಿಜನ್ ದೇರ್ ಇಸ್ ನೋ ಡಿ ಆರ್ಬಿಟಲ್ಸ್, ಓಕೆನಾ. ಸೊ ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ, ದೇರ್ ಈಸ್ ನೋ ಫಾರ್ಮೇಷನ್ ಆಫ್ ನೋ ಡಿ ಆರ್ಬಿಟಲ್ ಸಿನ್ಸ್ ನೋ oxidation state, that is +4 and +6, I mean does not show oxidation state +4 and +6, okay na. So whereas remaining other elements, it shows, I mean it is having d orbital and it shows oxidation state, that is +4 and +6 state, okay na. Next this is paramagnetic in nature. Why paramagnetic? That is presence of unpaired electrons, okay na, whereas other elements are diamagnetic in nature, okay na. Here H2O forms hydrogen bond, okay na. Here H2O forms hydrogen bond, means oxygen reacts with hydrogen to form water, that is due to formation of hydrogen bonding. whereas here the hydrides ಏನು ನಮಗೆ hydrides ಇದೆ those does not show or sorry do not show hydrogen bonding. Understood? So oxygen is a diatomic where others are octatomic in nature. In oxygen there is no d orbital, hence it does not show +4 and +6 oxidation state, whereas in other elements it has other elements have d orbital, hence show +4 and +6 oxidation state. Oxygen is paramagnetic in nature, whereas other elements are diamagnetic in nature. Then oxygen reacts with hydrogen to form water, that is due to formation of hydrogen bonding, where other elements reacts with hydrogen to form respective hydrides but does not show hydrogen bonding. Okay na? So these four are the anomalous behavior of oxygen. In your exam they will ask the mention any two or any three anomalous properties of oxygen, where you have to mention these. Okay na? So compare ಮಾಡೋ ರೀತಿನೇ ಬರೀಬೇಕು. ಕ್ಲಿಯರ್? ಸೊ ಜಸ್ಟು ಈ ರೀತಿ ಬರೆಯೋದಲ್ಲ. ಸೊ ನೀವು ಅದನ್ನೇನು ಮಾಡಬೇಕು, ಕಂಪೇರ್ ಮಾಡಬೇಕು. ಆಕ್ಸಿಜನ್ ಇಸ್ ಡಯಾಟಾಮಿಕ್ ಇನ್ ನೇಚರ್ ವೇರ್ ಅದರ್ಸ್ ಆರ್ ಆಕ್ಟಾಟಾಮಿಕ್ ಇನ್ ನೇಚರ್ ಅಂತ. ಸೊ this is about the anomalous behavior of oxygen. In the next class we are going to read about the compounds of oxygen, that is dioxygen.